What does warming do to our creation? It's been quite a week, also in terms of the environmental movement. And it's wonderful to see all these young people gathered around the world and protesting the status quo. They had a special youth summit yesterday, and the Secretary General of the United Nations said he went from a pessimist to an optimist, listening to the young people talk about what can be done and what needs to be done. This coming week will be a special session of the United Nations in New York to talk about some of these hard realities of how we make the transition from fossil fuels to a new economy. So there's going to be a lot of debate and discussion, and we'll be picking up some of those issues in subsequent sessions as well. So, last week we looked at this slide, which showed the changing carbon dioxide level as a result of the use of fossil fuels in our economy. And we see that it's increasing at a pretty steady rate. And that is, of course, the concern when I talk about greenhouse gases and how they function, that the more greenhouse gases we have, the greater will be the energy trapped in the Earth's atmosphere. Next. So some of the impacts then that we'll be sort of talking about is changes in weather patterns, melting of glaciers and ice fields, more intense storms and rainfall, higher death rates, loss of species, wildfires, food production, and there's a whole other list of things we could add to this, but these will be a few of the things that we're going to be at least alluding to, some in more detail than others. So what is the difference between weather and climate? Well, weather is really what we observe from day to day. Today was a lovely day, hot even. Weather involves long-term changes that we observe in the Earth's weather patterns. Is it getting wetter? Are the seasons getting longer or shorter? Are we getting colder or warmer days? And so climate is really what we're talking about. You hear people saying, well, thank goodness for global warming, especially in the wintertime. Well, that may or may not happen, that it's going to necessarily be warmer in the winter. We do get more extremes as we have different weather patterns, and we'll see why some of that happens. It's predicted that the future climate will have more violent storms and heavier precipitation. And so why is that? Again, as scientists, we like to ask the question, why does that happen? How does the creation function? Well, warmer air leads to stronger convection currents. And as you know, when you have your stove on or you have a candle burning, you can feel the warm air rising up and hitting your hand. And that's because of convection current. The air is heated up, it becomes less dense and rises. And that happens on a large scale as well. In fact, the winds that we experience are really convection currents caused by changes in temperature in various parts of the world. If the whole world were exactly one temperature, the convection currents would be minimal. But thankfully they're not, it's not. And so if you have, especially in the summertime, the difference between day and night on shore, you tend to have a change in the direction of the wind. As the land cools down in the evening, the warm air tends to come from the water and onto land, and as the land warms up during the daytime, the air tends to move in the opposite direction. So the greater the temperature difference, the more intense the convection currents and the more intense the wind then. Also, at a higher temperature, the rate of evaporation is faster. Again, I think all of you are familiar with that. On a warm surface, the water will evaporate a lot faster than on a cold surface. And that also affects the density of air. How does that affect the density? Adding water vapor as a gas now to the air. Is it going to increase, decrease, or stay the same? You're adding something to air, right? And so you expect it to get more dense. But that's not right. And we need the next slide. Oh, I think we're missing it. There we go. Water vapor is H2O, and that has a mass of 18 atomic mass units. We won't get into chemistry of that, but it's just a relative number that we'll use. Oxygen molecules are O2, and it weighs 32. Nitrogen is N2, and that's 28. And you can see that the water molecule is actually lighter than oxygen or air, or nitrogen molecules. And one of the basic laws in chemistry says that if you've got these three balloons, all the same size, they'll contain the same number of molecules. So equal volumes of any gas at the same temperature and pressure will contain the same number of molecules. That's a very basic law involving chemistry. That's why a hydrogen balloon will rise. Whereas a balloon filled with oxygen and air basically just kind of goes down because of the weight of the balloon itself. Air actually becomes less dense when water vapor is added to the air. And that's because the air molecules, oxygen and nitrogen primarily, that makes up 78% of 99% of air molecules in here. 99% of the air molecules are oxygen and nitrogen. When you add water vapor, some of the oxygen and nitrogen molecules are displaced. So the overall air actually will have a lower mass for a fixed volume, which then also adds to the lower density of air and hence strengthens the convection curves that you get with less dense air. Any questions about that? I know it's intuitively, it doesn't make sense, but that's the way it is. Cindy. That's Denise, I mean.
So where does the oxygen and nitrogen get displaced to?
Where do the oxygen and nitrogen go? Somewhere further out.
Like into the atmosphere?
Yep. Or they may be compressed a little bit closer together. So where does the oxygen and nitrogen go? It still stays in the atmosphere, but it's just that in a, let's say, a 1 liter volume, you now have a lower mass. For the air that has higher water vapor in it. And we also always have to compare, this is now on a global scale, the difference in air density between different regions. because that's what causes the winds. Okay, next. Some data then on the hurricane season. From 2017, we actually had 3 major hurricanes originating in the Atlantic. These were some of the first Category 5 hurricanes being generated in the Atlantic Ocean. 2 of them hit Puerto Rico, and one of them hit Houston, Texas, causing a tremendous amount of flooding. The estimated damage from just those 3 was over $200 billion. Next. Hurricane Florence, which hit the coast of the Carolinas last summer, just over a year ago, and hung over the Carolinas and other parts of the U.S. for days, dropping a phenomenal amount of water. More damage was done by the water than by the winds. Next. So here you see some of the pictures of the flooding caused by Hurricane Florence. Vast areas were flooded. The estimated cost for this hurricane, I just looked up some of the numbers, was around $45 billion. And that doesn't include all the other costs associated with damage to wildlife. This is just the cost of human structures and infrastructures. Next. The cyclones this year, there have been a number of them as well. Idai in March 2019, it was the worst tropical storm to hit southern Africa on the east coast. It affected 3 countries, Mozambique, Zimbabwe, and Malawi. Over 1,000 people were killed. In this case, the damage seems a lot less, but it's also because the infrastructure is not nearly as highly developed. And so the cost of housing and so on is also much less in terms of replacing. Another cyclone came very shortly after this one, in May, headed towards India and Bangladesh, but the weather predictions were such that they were able to relocate about 1 million people out of the path of the cyclone, with the result that there were a few deaths. There's still a lot of damage. Yes? Oh, the hurricane, cyclones, and typhoons, they're basically all the same. It's just that they're in different regions of the world. Yeah. So hurricanes are the ones that we have here in North America. Typhoons, part of the Philippines. Cyclones, I think, are, there's something usually they're changing.
I thought tornadoes were on land and hurricanes over water. No?
Not necessarily. It's not limited to that. Okay, next. And here you see the satellite picture in which you have a phenomenal amount of land. I've also given the map there. Most of Mozambique is actually was inundated by this particular cyclone. And they had so much water. And that causes a phenomenal amount of damage to God's creation as well. It affects agriculture. It causes a lot of erosion. It destroys wildlife habitat. Next, David. In August, India got hit by some really heavy monsoons. Monsoons are the annual rains that come in, but the monsoons are becoming more and more irregular. And so here you have just an aerial view of one of the cities after heavy rains, with at least 157 dead, according to some sources. Why why is it that these winds are so disruptive? Well, let me do a little demonstration as well. I'll just take a sheet of paper and hold that to my lower lip, and when I blow on it, you notice that the paper goes up, right? It actually gets lifted up. And the harder I blow, the more rapidly the paper will be lifted up. That's one reason why you often have the roofs of houses being lifted off the house, because of the forces caused by really rapid winds. What it does is, again, has to do with Bernoulli's principle. Some of you may not have heard of that, but what it says is that when any fluid is moving really fast, it creates a low pressure. Bernoulli's principle. And so when I'm blowing, I'm creating a low pressure above the sheet of paper. And the higher pressure below lifts it up. And that's also one reason why a hurricane and a tornado can just pick up trucks and houses and garbage and buildings and so on land when you have these tremendously high winds. We're talking about winds going 300 kilometers an hour in these hurricanes and in tornadoes as well. Just a year ago, tornadoes hit some towns just outside of Ottawa, doing a tremendous amount of damage. The tornadoes are certainly not as widespread as the hurricanes are. Some of the pictures that you saw here show that the hurricane's effect is over a very vast geographical region. So next study. So what then causes the extreme flooding associated with major storms? Well, we get more precipitation. And that's because warm air can also hold more water vapor. So for every degree rise, you can get an additional 7% water vapor. And as we saw, when you have water vapor in the air, it becomes less dense, and hence you have stronger convection currents between the cool and warm regions. It also transfers a tremendous amount of water from the oceans, because that's where many of the hurricanes begin, over the oceans. And that gets then transferred to land. And as it cools down over the land, the hurricanes start to release the water in torrential rain. And that can result in severe flooding, as we saw already earlier, landslides, soil erosion. If a farmer has crops in already, it can just wash the seeds out, as has happened with some farmers as well. And associated with that is that the precipitation is not as predictable as it once was. The monsoons, when they do come, can be extremely heavy, or there might not be much rain, or it can come at the wrong time. How do farmers then know when to plant their crops? Next slide. This is just a quote from an article on the Indian floods. Irregular monsoon has become a new norm for India. This year the monsoon was severely deficit. What that basically means is that early in June, they didn't get nearly as much water as they normally And then it was followed by very heavy rain events in June and July, which then leads to the kind of flooding that we saw earlier. This is now an emerging pattern for India's monsoons. Increasing drought, intermittent with heavy rain. And Mr. Cole said that the extreme rainfall events in India have tripled between 1950 and 2018, with many resulting in devastating floods. He put the damages at about $3 billion per year. Again, that seems small compared to what the damage is in North America, but again, you can understand why it seems a lot less. $3 billion for most people is a lot more than $3 billion for us. Hurricane Dorian, which hit the Bahamas just recently. A Category 5, it kind of developed as it was actually over the Bahamas. It intensified from just a tropical storm to a Category 5 storm in just a matter of a few days. Why is that? Because the Atlantic waters are warm, which intensifies the convection currents. A lot of evaporation is occurring, which also then intensifies the convection currents. And so it's the warm waters of the Atlantic that, in a sense, give energy to these hurricanes. It took a long time for Hurricane Dorian to actually move through the Bahamas, doing a lot of damage. And of course, it also hit Nova Scotia, causing a lot of local flooding there. Next. Associated with hurricanes is also a storm surge. You've probably heard of storm surges where as a hurricane reaches land, the water tends to get really high. Part of that is caused by the winds pushing the water, the waves pushing them in one direction, and when they hit the shore, they pile up and will go quite a ways inland. A second reason is that because of these high winds, the air pressure, as I mentioned earlier, is going to be lower inside a hurricane. And when the air pressure is lower in the hurricane, the water will actually rise. There's a difference in pressure between the area where there is no hurricane to where the high winds are. And that causes the water then to go to the low pressure area and actually rise. And that together with the winds pushing the water can cause some pretty severe storm surges that will bring the water level up, 4 or 5 meters higher than it normally would from a high tide. Next, we're going to now have Naomi say a few things about her work and some of the things that World Renewed is experiencing.
Thank you, Henry.
Okay, hi everyone. It's a pleasure to be here with you, and I see a lot of familiar faces, which is nice. So thank you for being here. I'm going to talk a little bit more specifically about how all of this intersects with World Renew's work. First, thank you, Dave. We're making him try to do double duty tonight. Okay, so specifically, how does climate change affect the poorest countries in the world? There's more to this as well. We'll talk about it as we go. This picture is actually from the effects of Cyclone Idai that was just mentioned by Henry. So you can see how much water, the water that you got that aerial satellite shot of, this is what it looked like on the ground. So pretty devastating. How many of you have heard of World Renewed? Awesome, okay. So how many of you know what that little slogan underneath the logo says? justly, loving, mercy, serving Christ. And that's based on Micah 6 verse 8, which a lot of us are familiar with. And so this is why we care about climate change, because we believe it's a justice issue and a mercy issue. And many of you may be familiar with disaster response services. How many of you have ever volunteered with disaster response services? Amazing. And so you know what it's like to go into a community that's been impacted by this kind of weather and to dig out mud or rebuild buildings. And in the United States especially, a lot of us have seen what that devastation looks like. Let's go to the next slide. So I'm going to make you do a little exercise because I think I'm a teacher at heart, and so I always want class participation. Okay, so the question is, how does your place in the world change how you would be affected by the climate crisis? So I want you to find a partner. You can do groups of 3 if you really want. And I want both of you to imagine that you're a farmer whose field has been destroyed by some kind of storm. But one of you lives in Alberta, and one of you lives in Tanzania. And I want you to talk to each other about how you were affected differently by this storm. I'll give you about 60 seconds. Go. Okay, you're doing great. I'm sure you can keep going, but can someone give me a few examples of some differences that you discovered or imagined? Yeah. Okay, let's go with that one. Insurance. Okay, I was just talking to a farmer in southern Alberta who had been affected, a cornfield wiped out by hail. I said, I'm so sorry. And he said, well, we have insurance. I mean, yeah, it's terrible. It was a big hit, for sure, but we have insurance here. And a farmer in Tanzania? Not at all. Nothing close. Any other differences?
The government, what do you?
Supporting to get out of disaster.
Yeah.
Fantastic, thanks, Marguerite. So some governments would be able and ready to help support farmers who are facing a crisis. Some governments are either corrupt or just don't have that kind of resource, right?
Yeah, the poorer places, they would have no infrastructure, so the ability to get in there and do it is very, very limited.
Absolutely, great point, thank you. So Henry was talking about how the difference in dollar figures between a disaster that happens in the States and a disaster that happens in places overseas is so vast, it really doesn't give you the whole story. Because the infrastructure is considered less valuable. That's a whole other session. And so we would call that impact less severe. Anyone else? Any other thoughts? It's almost like it's more work lost because so much of the work in a place like Tanzania would be done by hand or with very rudimentary machines. Whereas in Alberta, there's all kinds of big tractors and machinery and all kinds of stuff. Anything else that jumps to mind?
This poverty, I think in Tanzania, in fact, the farmers live with the biggest salary. Perhaps the extra money you would have had in the law sent us children to school, so I think it has much more personal impact on people's lives.
Yeah. All the other things that get subsidized in a culture like ours, like education, for instance, wouldn't be impacted by a natural disaster or by a crop failing the same way that it would in Tanzania.
So the emotional toll in Tanzania would be extreme, whereas in Alberta, I'm guessing farmers know how to roll with the weather punches.
And that's not to minimize, right? It's not saying that it's not a serious thing for an Alberta farmer to lose a crop. It is. But it is a different story, very much. One of the pieces that we want to think about a little bit is that for many farmers in the global south, their field is their only field. So they're probably eating food from that field and selling food from that field. And when it's gone, everything's gone. Whereas most of the farmers that I know in Alberta have a diversity of fields, right? They've got several different options for their harvest. Again, it depends, but as a general statement. Okay, so thank you for doing that exercise with me. I think it puts us in the mindset a little bit of what World Renew is talking about when we talk about the work of justice that we're doing. So there's so many stories to tell. I tried to narrow it down and focus it a little bit. And so the first thing we're going to look at is natural disasters and how they impact people around the world. And I'm just trying to share a few more specific examples so that all of the data that and those big numbers that Henry is sharing become a little bit more real to you. So, this is Cornelia Desir, and she lives in Haiti, and she was affected by Hurricane Matthew in 2016. She lost family members, she lost her crops, she lost her garden. That means she lost all of her ability to feed herself and her family. A church in Canada partnered with her community, and they helped to rebuild and replant, and so she is feeling quite positive about life, which is amazing, but it took a lot of work to get there. Her children have decided to stay on the family farm, which is pretty unusual. Most young people go to the city to work, and so the fact that they decided to stick around and learn farming is remarkable and speaks to the rebuilding of her livelihood. So it was a seed distribution program that helped her to rebuild her farm. And so the last we heard from Cornelia is that she planned to enjoy her next harvest and sell surplus at the local market. Very cool, right? But next slide. What could be some of the setbacks that could affect Cornelia due to climate change? Here are a few that I thought of. Failed crops. Just seasons that aren't quite what she expected, and therefore the planting season gets thrown off, and her crop just doesn't grow the way she anticipated. Homes getting destroyed by flooding, erosion that might affect the field as well. Again, the rains, the seasons just being not what was anticipated, too late, too early, too much, too little. Long droughts are also an issue for farmers. So any of these kinds of effects that seem fairly minor to us, probably, to her could literally be life or death because they affect that one field that she managed to rebuild after she lost everything due to a natural disaster. So far as of June, end of June 2019, 7 million people have been displaced this year. The last several years, it's been around 20 million every year, displaced only due to natural disasters. That's not including civil unrest and war and that kind of thing. So, for those folks who live in a refugee camp, this gentleman is a Syrian refugee in Lebanon. How does climate change affect them? Any ideas? Have you read anything about this? Anyone? If you're living in a shelter that looks like this, and a flood comes, a winter, icy, cold, sludgy flood comes to Lebanon, what happens? Sickness, cold, a lot of people have passed away in these camps. Just this past winter, there was a very bad storm, and it cost several lives. Next slide. This is in the Rohingya refugee camp in Bangladesh. This is an interesting one because it is really this city set up on like a hillside somewhere. They've actually had to clear a lot of trees to make room for this camp, which as a result means that when rains come, what happens? Yeah, landslides. So people's homes, the little home that they've been able to rebuild after they left their own home with nothing but the clothes on their back, gets washed away. And so there are people who we've helped over the last couple of years by getting some kind of, cooking stoves and just some basic needs. And those items just got washed away. Again, people have passed away in this camp because of those terrible conditions. This also means that waterborne diseases become more of a problem in those camps as well. Okay, next. So, in short, refugees are at risk. Even further, they are sort of the first ones to suffer when climate change results hit their region. Shelters are destroyed, there's food shortages, all the stuff that we talked about. Next. Okay, so what about the ongoing challenges? How does this affect your average farmer, like the one we were imagining in Tanzania? What all of this makes me think about is something that this gentleman from the UN, Philip Alston, is calling climate apartheid. And you may think that's a very severe way to talk about it, but his point is that climate change threatens to undo all of this development work that we've been working on for the last half century, that we've put a lot of our resources toward. We've tried to help communities build and grow, but when they have such a small margin for any kind of loss, climate change is affecting them much more quickly. So the statistic I read in The Guardian said developing countries will bear an estimated 75% of the costs of the climate crisis, despite the poorest half of the world's population causing just 10% of the carbon dioxide emissions. So they're the least responsible, bearing the biggest impact. This is an example of someone that we've worked with on an ongoing basis. He's a farmer in Honduras, and Lazaro says he had this land that just wasn't productive. He wasn't sure about the rain, and he just couldn't trust his weather patterns the way he used to. And so he's worked on diversification, grafting. We've got this whole field called conservation agriculture that involves things like planting trees and different kinds of cover crops to help conserve moisture and help the crops grow better, different kinds of composting techniques. You can learn about all of this, if you like, on our website or by talking to me afterwards. But basically what happens with farmers like Lazaro is that they take this useless land and turn it into productive land. So there are ways to still make the land produce what is needed, but techniques have to change. You have to try new methods. You have to employ different practices to be able to get there. Just one second. Another thing that we're encouraging is for farmers to diversify their livelihoods. And so another thing that World Renew does is provide training in different kinds of small business practices, something like learning how to sew, or starting a small business selling donuts, let's say. Those kinds of things can help a farmer, if they can't really trust their crop the way they used to have an income year-round. So recently, one of the issues that's come up is this drought in western Zambia. And so again, we're trying to use conservation agriculture there. But this was in our latest newsletter from Zambia, which you can sign up for if you want by speaking to me afterward, or any of our country newsletters. But there's a Reverend Kanchele, who works with the United Church of Zambia, and I'm going to read the whole quote to you because he wrote it to us, and I thought it was very powerful. He says, "If we lived in a world that was fair and just, these problems would be something we could address ourselves. But because we haven't caused these changes in our climate, we alone cannot solve them. We need richer, more polluting countries to change their behavior and cut their emissions rapidly if if we're going to hold back or even reverse the devastation of climate change and its effects. This crisis is global in its nature and making, and as such, we must see this as an opportunity for the world to act together in solidarity and fairness. In Zambia, for instance, we have almost limitless potential for clean energy, but we need the funding and the support to unlock it. We have renewable resources of wind, sun, and water with which we can power our entire region's development, but we don't have the finances, technology, or expertise to harness them. If I have one message to our brothers and sisters in the USA and Canada, it is this. It is vital that you and your governments heed the warnings of UN scientists and cut your emissions urgently. You hold the lives of millions of the poorest people, not only in Zambia, but across the world, in your hands. And this responsibility and these millions demand that you do what is required to remedy the situation. That's the message from that pastor in Zambia, and that's the kind of thing we're hearing from the field. For the folks we work with, this is not a maybe. This is a reality they deal with every day. What can we do as far as World Renew is concerned? Henry will talk a lot more over the next few weeks about what exactly it looks like to address climate change and what kind of steps we can take. But like we just mentioned, there are ways to pray about this, and Cindy has some resources for you. I have some resources for you. You can certainly support this kind of work that helps stabilize life for farmers and other people around the world. You can visit these countries. We have something called Climate Change Boot Camp, where you can visit different countries and really start to understand what's happening on the ground. You can advocate, and that's another thing that we can talk to you more about at the table in the back. You can partner, your church or your group of friends or your family can partner with a community somewhere in the world that needs your support and make a huge difference. And of course, you can visit us online, worldrenew.net/creationcare, and learn a lot more about everything that's available there. We do also have a whole bunch of social media channels, if that's your thing. You can follow us on all these places, including YouTube, where we have a video about climate change in Bangladesh, which...
Thank you, Naomi. It's good to see as well what's happening at the ground level and what's happening to people's lives. As we continue with the impact on creation, we'll see that so much more is affected. Oceans absorb about 90% of the heat that is being trapped by the greenhouse gases. And that could cause then rising ocean levels, which further compounds some of the things Naomi talked about. When a land-based glacier melts, that water eventually ends up in the oceans. If it's an iceberg in the ocean, then the level doesn't change. But it's the land-based glaciers, when they melt, that leads to rising water levels. So, for example, in Greenland, you have a huge ice field, the Antarctic, the Arctic itself, glaciers around the world, in the mountainous regions. That will all contribute to the freshwater input into the oceans. And when things warm up, they also expand. Something we all intuitively know, I believe. So when water warms up, it also expands. And because the ocean is so deep, like the average ocean is about 3.5 kilometers deep. Can you imagine how far down that is? That's a huge amount of water. And if that warms up, even by 1 degree, and if it were uniform, which it isn't, but it can eventually become more uniform, you get about a 75 center rise just from thermal expansion. If all the water were to expand equally by 1 degree. And that obviously will impact any of the low-lying countries like Bangladesh and like many parts of the world. The Dutch are working already to strengthen and raise their dikes. And they have the technology, the know-how, and they make the resources available to do that because they know what happens if the dikes fail. Next. And so we're already seeing what is often referred to as sunny day flooding, or flooding that occurs during high tide without any storm. And Miami is located rather on low-lying land, and they are now seeing flooding occurred on a regular basis. They are spending billions of dollars upgrading their infrastructure to block some of that water that's been coming in to their cities and to the streets. Next. Sea level has been monitored as well by satellites. They have the capability of measuring things very precisely. And these are 4 different satellites data that have been sort of averaged out since 1995. We've had an increase of almost 10 centimeters. 10 centimeters, about that much. That's over a 25-year period. Not all that long in terms of history. And if that continues, you can imagine what will happen next. Another thing that happens is that carbon dioxide is classified in chemistry as an acidic gas. We use it in carbonated beverages. It gives a kind of a sour taste to it, which is typical of acids. But when it dissolves in seawater, it forms carbonic acid, which then releases hydrogen ions that are responsible for the acidity. And the pH is a measure of acidity. A pH above 7 is classified as being basic, and below 7 is classified as acidic. The pH of the ocean is normally about 8.2, so it's slightly basic. It has dropped to 8.1, which doesn't sound like very much at all, but that's a 25% change in the amount of hydrogen ions in the water, which are responsible for the acidity. And that's because we're dealing with a logarithmic scale, for those of you that are into the mathematics. Next. And that has an impact on many creatures within the oceans. You'll notice that the top 2 categories up there, fresh algae and diatoms, they experience an actual growth. 22% growth for the algae and 17% growth for the diatoms. Any creature that uses calcium carbonate for its shell experiences a very significant decline. Calcifying algae, 80% decrease. Clams, 34% decrease in survival. So that many creatures are affected by the change in the pH, which in turn affects the whole food chain in the oceans, which in turn affects the livelihood for many people that depend on fish for their protein and for their livelihood. So there are significant changes in the biology of the ocean simply because the pH is changing. Next. Here's some pictures showing the impact of warmer temperatures as well as changing acidity. So in the upper left, you see healthy coral. In picture 2, it's bleached. In picture 3, you see algae growing on it because they grow well under these conditions. And in picture 4, you see a lot more algae growing on it. The coral is dead. And that's also happening to the Great Barrier Reef in Australia. And many other coral beds are also dying around the world, which again impacts the local citizens because corals, or the coral reefs, are extremely abundant in life. But when they die, it affects the whole food chain again in that region. A few things about glaciers. 68% of all the fresh water in the world is actually tied up in ice. And found in the glaciers and in the ice caps, the Antarctic, the Arctic, the ice on Greenland, and so on. Glaciers help to moderate the Earth's temperature. It's like putting an ice cube in your drink. Your drink is going to stay cool as long as you've got ice in there. But once the ice melts, the temperature starts to go up. And so the glaciers also help to moderate the temperatures in various regions around the world. In addition, the presence of ice and snow on the ground actually reflects solar energy back into the space through the atmosphere. As we saw last day, when it's the heat energy, the thermal radiation, or the thermal infrared radiation, that can get trapped by the greenhouse gases. But if the solar energy reflects directly into space, it is not absorbed by the greenhouse gases, and so it goes into space. But once that ice is gone, there's nothing to reflect it into space. So what does it do? It warms up the ground or the water, whatever the sunshine falls on, that is converted into heat and contributes then to the higher temperature of the Earth. About 90% of the glaciers worldwide are actually retreating. 90% of them. There are a couple that have remained stable. A few are growing in a few places, depending on how much snow they get. It's this annual snow amount that will determine whether or not they will grow. If there's an excess amount of snow, more snow than melting, then it's melted, then the glacier will grow. But the vast majority are retreating. The glaciers also serve as water storage. It's again God's provision for his creatures. So there is fresh water available in the summertime. When the glaciers melt, it feeds the rivers. The Ganges River, the Saskatchewan River, the Athabasca River, the Columbia River, they're all fed by glaciers in the summertime. If they melt too fast, you get a lot of water coming initially, and it gives you the impression that there's lots of water, we can do with it what we want, but as soon as those glaciers start getting depleted, that water supply is being cut off. And we have to learn to live with a lot less. Much of the agriculture in southern Alberta, for example, is possible because of the glacial life melt from the Columbia ice field. It feeds the North and South Saskatchewan rivers and provides then a steady flow of water in the summertime. Asia depends on much of its fresh water for irrigation purposes and for drinking from the Himalayas. And there too, the glaciers are retreating. The glaciers on Mount Kilimanjaro are basically extinct. There's very little ice left on top of them, and so the local villagers that used to depend on the spring or the summer melt no longer have that freshwater source available for them. Next. Just a few pictures of some different glacier retreating. The bottom picture is from 1920, the top 2005. You notice it's the same location, but notice the difference in the amount of snow and ice. Next. Muir Glacier in Alaska from 1941 to 2004. How different that is. Next. This is the Athabasca Glacier in Alberta. Many of you may have visited it at one point or another, right? And you realize now how far the front of the ice is from the road. You used to be able to, it used to go right up to the road, now it's several kilometers in. It's caused by a retreating glacier, and not only does it get smaller in length, it also gets smaller in depth. So it's not just melting in one dimension, but it's actually melting in all three dimensions. Next. The Athabasca Glacier, which is part of the Columbia ice field, actually feeds the water for the Athabasca River. The Athabasca River also goes through the tar sands. A lot of the water is being used by the tar sands operations. And eventually it flows into the Lake Athabasca, and from there into the Mackenzie River, and there eventually into the Arctic Ocean. It has retreated about 2 kilometers since the 1800s. So that's a lot of water that's been lost. So will there be water available in the future? We don't know. Next. Chile, too, has been experiencing a lot of drought. And they've got some of the worst drought in 60 years. The picture that you see there is one in 2013, a lake that was being used by the locals for recreational purposes. And this is the way it is today. There's a very serious shortfall of water for the capital, San Diego. Where are they going to get their water from? They had similar problems in South Africa a while ago, with the reservoirs being almost depleted. And we just can't live without water. We can't live without water. And the rest of the creation suffers when there's not enough water. Now, climate change is considered to be one major source. It's probably not the only source. It's also mismanagement often of water supplies. Excessive amounts of water may be drawn from reservoirs or rivers to be used for agricultural purposes or for industrial purposes. So there's usually more than one factor, but one of the factors that we really can't control so much is the climate change that happens. Next. The Arctic, too, is changing rather rapidly. In fact, some of the most rapid effects of climate change are being experienced in the Arctic. The temperatures are rising there about twice as fast as elsewhere in the world. The Arctic Ocean is now ice-free in many parts, to the point now that ships can travel between China and Europe through the Arctic. We've got cruise ships going up into the Arctic, bringing tourists into the Nunavut area. That probably can't be all that good. For one, they would never be able to handle all the people that are on one of these cruise ships. But another problem is that more open water also absorbs the solar energy directly, which then warms the water even faster. It's often what we call a feedback mechanism. So one thing leads to something else and simply intensifies the problem. Ice or snow, as we said already earlier, reflects the solar energy, whereas open water or exposed soil will absorb it and convert it into heat energy. Next. So this is just a schematic showing the role of sunlight, of ice, snow with respect to water. So 90% of the sunlight is reflected from a body of ice. Only 6% is reflected from the water surface. The other 96% is absorbed and converted to heat energy, which then warms the water fast. Next. What has also happened is that because of our widespread use of fossil fuels with their emissions, soot is deposited on ice around the world. The black smoke that you see coming out of a diesel truck, that's carbon particles. And they are so small that winds can carry them all around the world. And these carbon particles can be deposited on ice, and when the sun shines on the ice, rather than reflecting it, it gets absorbed and converted to heat energy, which melts the ice and speeds up the rate at which the ice or snow melts. And that, of course, leads to higher temperatures. So in some areas, the temperature of the Arctic has risen by 4 degrees Celsius. Last winter, there were times when it was warmer at the North Pole than where we are. And that has to do with changes in the atmosphere. It also leads to thawing of the permafrost. The permafrost, by its very nature, is permanent all year round. That's why we call it permafrost, permanent frost. But when it warms up, the permafrost melts, and when the permafrost melts, it destabilizes, it becomes almost liquidy, very muddy, it flows, and so the embankments along rivers and the Arctic Ocean, for example, can just slide into the water. But if you have any buildings built on the permafrost, all of a sudden your foundation is no longer solid and your buildings shift. When they build pipelines up in the north, they have to really take that into consideration. In some cases, they actually use cooling equipment to keep the permafrost frozen in order to prevent the pipelines from moving. And as the permafrost warms up, it can decay, and bacteria will break down some of the organic matter that's in the permafrost, which then releases methane, one of the greenhouse gases that we talked about last week. And there are also these methane hydrates. I referred to them last week briefly as well. When the ocean warms up, some of these frozen forms of methane and water, which we call methane hydrates, they will decompose, releasing methane gas into the atmosphere. Another feedback mechanism which intensifies the overall impact. And of course, it's also a justice issue, again, that Naomi talked about so much, because the way of life of the indigenous peoples being extremely affected by the changing seasons and the changing effects of the sea in the Arctic. How can you maintain a way of life that is dependent on the permafrost and the ice for hunting, fishing, and so on? Next. The Greenland ice sheet is the second largest ice field in the world. Only the largest is the Antarctic. So you have a vast reservoir of water in the ice in Greenland. It's between 2 and 3 kilometers thick. Can you imagine that? An ice field way up there. And approximately 2,400 kilometers long, 1,100 kilometers wide. Obviously not a rectangle, but irregular. Those are some of the extremities. So a huge reservoir of water. This past summer, when Europe had its heat wave, where temperatures went up into the high 40s, some of that warm air actually continued to flow west and over Greenland. And that led to extremely high, rapid rates of melting of the Greenland ice fields. And there are some pictures of some of the lakes that are formed and the rivers that come off the ice fields as the water melts. That all takes heat energy. If the ice isn't there, what's going to happen to that heat energy? It's just going to raise the temperature of the atmosphere more and more. So we have to ensure that some of those ice fields remain stable. Next. Here you see a sort of a graph showing temperature changes between 2014 and 2018. It's only 4 years. And what you notice in particular is that the biggest temperature changes occur in the Arctic, the north. And there's that interesting blue spot just underneath Greenland. That is most likely due to the meltwater from the ice fields. Because you have such a volume of water, cold water coming into the Atlantic that it's actually cooling the water down. And fresh water is less dense than salt water, and so it will tend to float on top of the salt water. And so when you have the temperatures being recorded by satellites, it will show up as a cooler region. Next. It's believed that the changes in the atmospheric temperature result in the jet stream changing its location. So instead of having it more or less smooth around the upper part of the Earth, as you see in the top picture, it actually goes way down at times, which then allows for cold air to flow into southern Europe, for example, or into southern USA at times when they have the frosts in Florida. or frost in southern France, or snowfalls in Vancouver. There's so many factors that affect this. There's belief that the jet stream is no longer stable, caused by the differences in temperature in the atmosphere, which then leads to some of the strange weather patterns that we are observing. Next. Wildfires, another huge side effect. Fort McMurray, a wildfire that lasted for several months. The cost was estimated at about $9.9 billion. The costliest disaster in Canada. About 1.5 million acres were burned, a forest area. That also releases a lot of extra CO2 again into the atmosphere. Whenever we burn trees, any wildfire releases extra CO2. The atmosphere can't tell the difference between the CO2 coming from plants and coming from fossil fuel. It's the same stuff. And it has the same big impact on its operation as a greenhouse gas. It's a huge fire, just one of many. Next. In BC, they've had a lot of fires recently. In part, it's caused by the mountain pine beetle. The mountain pine beetle is a native beetle in BC, southern BC, and because of cold winters, its population was controlled. So winters are cold enough that it actually killed off some of the pine beetle larvae, so that the next season there would only be a few around that could start doing their damage. So it's a native plant, a native insect, I should say. When it warms up, many more of these pine beetles are now able to survive, and so come springtime, you already have a lot of pine beetles living in the trees, and they're voracious eaters and multipliers. And within a very short time then, you have an infestation, and trees are no longer able to defend themselves against the impact of climate, of the mountain beetle. Leading then to what you see in the picture of the forest, dead trees. And that, of course, is very susceptible to burning by any kind of fire, whether started by humans or by lightning or other means. Next slide. This gives you kind of a graph of the intensity of some of the fires more recently. So the blue line represents the greenhouse gas emissions, and the red line represents the total area burned. And what you notice is in the last number of years, the area burned has been increasing. And certainly in 2018, there was a huge increase in the amount of forests that were burned by these wildfires. Next. In Brazil as well, we've been hearing about that, because the Amazon is treated or considered to be the lungs of the earth. Again, a vast reservoir of forests, green plants that can take in carbon dioxide, release oxygen, and fix some of the carbon in terms of plant matter. Part of these fires are caused by logging, clearing of land. Part of the fires are, again, caused by natural causes. But we're looking at 165,000 fires in the Amazon region this past summer at any one time. That's a lot of fires. It's a lot of carbon dioxide going into the atmosphere. It's a lot of trees being destroyed. And that again changes the local climate. And you can say, well, we did that in North America. When settlers came here first, we destroyed a lot of the trees, we burned them, and we did. So shouldn't Brazil be allowed to do the same thing? So they have more agriculture than available. Unfortunately, soil in the tropics is not really suitable for agriculture. The amount of nutrients in the soil is very low. Even though we have a very lush ecosystem, it's because the ecosystem recycles its nutrients constantly. So when a leaf falls off the tree, it hardly ever makes it down to the floor of the forest, because it gets digested by insects along the way or bacteria, and the nutrients are then reused. So there's constant recycling, whereas over here we have a lot of nutrients in the soil. We have good agricultural land. And so you can grow grass for a number of years for your cattle, but it doesn't last unless you provide a huge amount of nutrients. And we can go on, but I'm going to stop. Next week.